And you got 7.98 also?
I got 7.9.
You got that, all right, so seems to be 7.5. Okay. This is not the answer you're looking for. All right, so now let's actually answer the question. If we were doing a test one, this is the whole thing's a legitimate test one problem where you first come up with the acceleration and then you've got a linear motion problem here. So this type thing that this, what we've done so far, is basically a test 1B kind of problem, and this is a test 1A problem. So we know, well, we got the 5 basic quantities, delta x, vi, vf, a, and t. We know 3 of them. Which of the 3 do we know? All right, that's what we just solved. 7.98 meters per second squared.
Initial velocity. Initial velocity
Is,
10 meters per second.
ooh,
Negative 10.
yes, that is critical. We said down the ramp was positive, so the initial velocity is negative 10 meters per second. And we know one other thing. That's what we're trying to find.
Final.
What's the final velocity? Do the whole thing.
Meters per second.
Thank you. 0 meters per second, and time we don't know. We don't need to know time because it's not really part of it. You could solve for time first if you wanted to. It depends on how you want to go about it.
You don't need to, right?
No, you don't need to. And the one equation we have without time is the Vf squared equals Vi squared plus 2a dot delta x. Now, is delta x, is the displacement going to be positive or negative?
Negative.
Why?
Because we're moving in a negative direction.
Yeah, we said down the ramp is positive and this thing is moving in the positive direction. Or sorry, try that one again. We said down the ramp is positive and it's moving it up the ramp, which is the positive. Did it again. I'm gonna blame the 251 students, not the fact that, I'm old. So we have 0, so delta x better be negative. Times 100 equals 100 plus 2 times 7.98 times delta x, and probably off screen. Hopefully they'll track it elsewhere. And so the displacement will end up being 100, negative 100 divided by 2 times that, which is 15.96, I believe. So somewhere around 6.
Maybe it's 6.27
6.27
meters.
meters. Yep. Vanita, would you like the cart? Would that help you?
Yeah, today is fine, but I will need it later. Thank you.
The cart probably should be over there anyway.
Yeah.
Oh. Okay, with the rods there, with the bases there. Oh, the small ones, they were mixed in with those. And there might be some in the interim room, the one that's connected to the long skinny room that's across the hall.
This open?
If this door is unlocked, then you should be able to get it from the classroom.
From 259.
Yeah, from 259, you've got the front desk right here, the door
Okay,
is
thank you.
right there. All right, so we've answered how far will the book slide, 6.27 meters up the ramp, which is the negative direction. Will it slide back down? Any questions before we address the sliding back down? And now now we'll use the magic of the fact that I have this stuff written all over the board. What is gonna change when I start to answer this question right here? What changes?
F of K.
What is it, to what, how does it change?
It changes to F of S.
Okay, is that it?
Yes.
What else changes?
Acceleration becomes positive.
Pardon?
Acceleration becomes positive.
Well, the acceleration was positive already, that doesn't change. We could change since it's a different problem, we could change our coordinate system if we wanted to, but we don't need to. We still can make we had down the ramp positive, and we'll just stick with that, So positive acceleration means it will slide back down, negative acceleration means it won't. However, there's one other, let's start bit by bit.
Oh,
Does the force diagram change?
I think so. Does the-
Why?
The tension changes? Is that right?
No, it's still attached in the same place. Ben? How?
It's greater, so the book won't be as far.
Not,
It would push it in the other direction, like.
which means in the force diagram? What does that mean for the force diagram?
The friction's in the opposite direction.
Friction would then become negative.
When it gets to the top, friction is acting down the ramp as it's sliding up, and as soon as it stops, friction flips. And so it is static. We have to consider the static case. And we now have, and let's see, how well is orange working today? Not too bad. And so this changes to f sub s going this way. The fk becomes f sub s, and was said is now negative. So this is negative u sub s here, negative u sub s, negative u sub s, negative u sub s. This is not 0.2 anymore, but 0.4, and it is negative now. And so this becomes negative 21.92. Because all I did was basically double the coefficient, so it should just be twice what we had before.
This is a break-even point.
Right.
We're
Yeah, that, if the maximum static friction is in play, what is our acceleration? So, if the friction is the maximum static, we get acceleration of,
4.32.
say it again,
4.32.
4.33?
30, yeah.
Therefore, will it slide back down or not?
Yes. Yeah, it will.
It will slide. Therefore, slides. And so the acceleration is not 4.33 because it is sliding. So in order to figure out what the actual slide is, the only thing we're doing is changing that 0.4 to a 0.2, making this negative 10.96, which will up that a little bit.
So if it was negative, it wouldn't, is what, like, that's how you would get the other answer?
Right, because I would expect, if it's gonna slide back down, the acceleration should be positive at that point. So a negative acceleration means it stops and then somehow it goes back up the ramp, which, you know,
That'd be awesome.
Yeah, it would.
only in math class could that happen. In physics class, we go, wait a second, that's not realistic. Oh, sorry. Okay. Did you get my good side? Is there a good side? Questions? Say it again?
This sound was a pterodactyl.
Oh. Is that what they sound like? All right, let me hand some stuff back. This counts as a quiz grade. Please don't be discouraged by it. It is just a grade, mini. So,
That does not, sounds like it's,
well, I mean, it's not all sunshine and roses. I mean, some people didn't answer all the questions, which immediately starts knocking you down. Some people had some misconceptions, and hopefully you'll look at those. And
These are the master set.
these are master set for chapter 2.
Is there a lot of partial credit areas and
There are a lot of what?
partial credit for example, like each?
I try. There's certain things though that if you do, well, in the two-dimensional, for like a projectile motion problem, you're supposed to plug in the vertical stuff into one equation, horizontal stuff into another. If you mix and match, put in, horizontal velocity and vertical acceleration, I tend to do that very harshly, because that's, missing a major point. All right, show me up.
Did you switch the test date?
That's 251. The test for you is on Tuesday. The next time we meet.
is there anything due for us Tuesday of the test?
No, the lab is due the week after. The lab that you did did 2 days ago,
Yeah.
normally is due in a week, but it's actually due the next time we have lab. If we have a test next Tuesday, it's not due then, but due the week after.
Gotcha.
Now, if you have the lab ready by next Tuesday, fine, you can hand it in, but I'd rather you spend time that you have studying for the test than working on the lab.
Understood.
Although, there will be a projectile motion problem on the test, in case you missed that thing first 5 times as much as it is.
It's gonna be one of the things that I take a roll.
Yeah, I know it's small, they.
And Martina. Probably stop this at this point.